Hi friends, welcome to my channel. Let's have a look at today's daily challenge problem, problem 704, binary search. I would say this problem is a very classic problem, but here we want to do this daily challenge problem, and meanwhile we want to emphasize or demonstrate several things that is important in the use of binary search. So here for checking a target in a sorted array or list, so it's a very vanilla task. So in general, binary search is a very powerful tool. It can be used to solve quite a large number of problems, both in academia and also in industry or in your day-to-day work. So here, let's look at the problem. So we are given an array called an integer array called nums. So this array is already in sorted order. So it's sorted in ascending order. So in other words, so this array, it already has an order, right? So then an integer target is also given. So we want to write a function to search if a target is in this nums list. So if the target exists, then we return its index. Otherwise, we're going to return -1. So here, this is a requirement. We must write an algorithm with a logarithm runtime complexity. This is a typical binary search, right? So for this problem, because the length is 10 to the power 4, it might be possible that you do a linear scan, right? And you can find the first occurrence of the target. So, but also in this problem, the assumption is that all the integers in nums are unique, right? So if we just want to check membership, so we can transform the nums array to be a set, and then we do membership check using the in operation. Then the net membership check after the transformation or type conversion, this is O1. But in a typical binary search, so the time complexity is O of logarithm n, where n is the length of the iterable involved. So here, let me first present a solution, and then we want to break the solution into of the binary search into the main ingredients, and then we discuss its general usage or general patterns or paradigm, right? And emphasize the main ingredients. So first, I'm going to get the length of this nums. So this is not essential, right? You don't need to introduce this variable, but introducing this variable brings us some convenience. For example, it's very easy to write some for loops without writing this long thing. And then what we are going to do, I'm going to write low and right, so to be the left index and the right index. So the right index is n-1, right? So here I'm writing low and right. Sometimes I will write L and R for left and right. But so writing one letter sometimes can be confusing, right? And then we have this one. Then we want to do the while loop. So here I'm going to write that while low is less than or equal to right. So notice that here I'm writing less than or equal for this vanilla usage. So this actually can be very important sometimes in the while loop condition. So we need to adjust this to be less than or equal or just strictly less. So in this problem, we are going to use less than or equal because we want to check the membership. And then what we are going to do, we are going to compute the middle. So this step, so I'm going to write low plus right minus low integer division by 2. I'm writing this format on purpose. So here, this is the base, and this is the increment, right? This is the right minus low is the search range length, and then the integer division by 2, this is the half, right? So this is the shrinkage. And then we're going to do some check clause. So here, let's see, if nums made equals target, right? So then we just need to return this index. So this is the easy case. So now let's look at the else if clause. So if this one is larger than target, right? Then I'm going to set the right to be made -1. So here I'm using -1 because nums made is already larger than target strictly. So otherwise, then I'm going to, because it corresponds to this number, nums at index made is less than the target. Then we're going to set low to be made +1, right? So this is strictly less than made, and this is strictly larger than made. So in some other usage, sometimes we just need to set it to be made or to be made here. And then what we're going to do, so if the target is inside this list, so we should already returned within this while loop. And if we exit this while loop without anything returned, so we're going to return -1, which means that nothing, this target does not exist. So in this problem, let's first make test. Yeah, it passes the second example. Now let's look at the first example. Let's change this one to be none. So one case is the target is not in the list, and the other is that the target is inside the list, right? Yeah, it passes this one. Now let's look at the generic case. Yeah, it passes all the generic cases. So here I would like to do a slightly extension. So here first I will say this is vanilla usage of binary search idea. That is check membership, check existence in ordered iterable or sequence. Actually, there are some other ingredients. So let me first see here the ingredients. So actually, basically, it's three things or two things if we group it into two. So one is order or monotonicity. The other is search range. So here is a search range in this problem, and the related one is the proper shrinkage. So how we do the shrinkage according to problem logic. And after this two, basically we need to have a proper return, right? So I'm going to write as this proper return. So sometimes we can return low, or sometimes we return right. Sometimes we need to return -1. And another thing we need to pay attention to is here, right? So for example, in this problem, we cannot write strictly less. If you check, this example passes, but you check. So there's some cases we cannot test, because this case 5 is inside, but because you have 0 and 0, right? So because it does not enter this while loop if you write strictly less. So this is the one thing to notice, right? So overall, so these are the ingredients, right? So we have a search range, so we have a condition corresponding to the problem logic, and then we do the shrinkage. So all these are based on the order. So in this problem, because it's a vanilla case, the order is that is given by the sorting order here, ascending order. So in the general usage pattern, so basically we're going to more general binary search paradigm as the following. First, we define. Maybe we do this. That's better, right? First is to define a Boolean function to produce order or monotonicity. So this actually enables the possibility to do binary search. The second step basically is determine search range, search space, and shrinkage. So these are all based on problem logic, right? And then we need to do proper return. So this is one example that we can use as a study example. So if you are interested, you can follow up my channel. So there's a playlist on binary search. There are many or a number of problems with different levels of difficulty. It can be you can practice or comments or invoke some thoughts there. So this is basically the paradigm. So another thing I want to mention in this video is that if you use different programming language, for example, here we are using Python. In Python, there's a bisect module, right, or bisect library. So you can use the bisect, say for example, bisect left and bisect right. You can use this methods to do a lot of works and very community. So actually, it's good to check. In some of our examples or practices exercise in YouTube, we have used this module a number of times. So actually, this is very convenient. But sometimes, if we wrote our own functions or modules, so we need to pay attention to a number of things, like this kind of thing. So it's less than or equal to, or just strictly less, and how to do the shrinkage. So from low to high or from high to low, depending on the Boolean function. Or what should we return, right? We return low or high or middle or -1. So all these things can be very subtle or delicate, but it's actually a lot of fun to do this kind of problem, especially when we grasp the essence or in a better level, right? So I guess with that said, that's about it for this classic binary search problem. Yeah.